Hello and welcome. In today's lesson, we are going to go more into depth on factoring trinomials by grouping. First, let's go ahead and recall our 4 steps. Step 1 when we are factoring a trinomial by grouping is to multiply the leading coefficient by the last term. Now remember, the leading coefficient is the very first number in your expression. In this case, it is a 1. So here I am going to multiply 1 by 30. 1 is my leading coefficient, 30 is my last term. Multiplying them together, I get 30. Step 2. In step 2, we are going to find two numbers that multiply to this number 30 and add to the middle term. So when I factor 30, one option is 10 times 3. These two numbers multiply to get 30, but also when I add them, 10 plus 3, I get the middle term of 13. Step 3, I'm going to rewrite the middle term with these two numbers. So all I'm going to do is break down this 13r into 10r plus 3r. So instead of r squared plus 13r plus 30, I'm going to break this down into r squared plus 10r plus 3r plus 30. It's the exact same thing, it just looks a little bit different. Step 4, we now factor by grouping. So looking at this expression as two parts, on the left I see a greatest common factor of r. When I factor that out, I'm left with r plus 10. I bring down my plus sign, and I can factor out a GCF of 3 from the right, leaving me with r plus 10. Now looking at the entire expression, I have r plus 10 repeated, so I may factor that r plus 10 out, leaving me with an r plus 3 in my second parentheses. Down below to the left, I multiply my leading coefficient of 1 by 36 to get 36. And now I am looking for two factors of 36 that add to 12. So previously, we have set these up as what we call diamond problems. So on the top, I'm multiplying to 36. On the bottom, I'm adding to 12. On the left and the right, my two numbers are 6 and 6. So I'm going to rewrite my 12 as 6k plus 6k. And then I factor by grouping. From the left, between k squared and 6k, there is a greatest common factor of k. So I factor that out, leaving me with k plus 6. And from the right, I can factor out a 6, leaving me with a k plus 6. There is a k plus 6 in common, so when I factor out the k plus 6, I am left with a k plus 6 in my second parentheses. Since this is the same thing repeated twice, I can simply write it as k plus 6 to the second power. To the right, I am multiplying to my leading coefficient, which is 1 times 28. I'm multiplying to 28, and I'm adding to 11. Two numbers that multiply to 28 and add to 11 are 7 and 4. So I split up my 11 as 7p plus 4p, and then I factor by grouping. From the left half, I see that there is a greatest common factor of p, so when I factor out that p, I'm left with p plus 7. From the right, I see a greatest common factor of 4. When I factor out the 4, I'm left with p plus 7. Now I take my greatest common factor of p plus 7 out, and what that leaves me with in my second set of parentheses is a p plus 4. Go ahead and take a moment and try these next 4 on your own after pausing the video. From the first, you should have n plus 9 times n plus 9, or you may break it down into n plus 9 all squared. Second, you should have a plus 6 times a plus 5. Third, you should have x plus 5 times x plus 4. And last, p plus 10 times p plus 1. Now we're going to talk a little bit about what if one of your numbers is negative. So my leading coefficient is still a 1 in this case. 1 times 16 is 16. So I am factoring to a positive 16 while multiplying to a negative 8. So now I need two numbers that multiply to a positive but add to a negative. So what I'm looking for are two negative numbers. I'm just going to make my list of possible options over here to the left. I need two negative numbers that multiply to 16. I could do a -1 and a -16. That adds to -17. I could do a -2 and a -8. That adds to -10. 16 isn't divisible by 3, so I'll go ahead and skip to 4. I could do a -4 and a -4, which add to a -8. So those are the two numbers that I am looking for. These two negatives multiply to a positive and also add to the -8 that I'm looking for. Now I rewrite my middle term of 8 as -4x minus 4x. So x squared minus 4x minus 4x plus 16, and I factor by grouping. From the left, I see a greatest common factor of x. When I factor that out, I'm left with x minus 4. From the right, I bring down this negative, and between 4 and 16, there is a greatest common factor of 4. Now I'm factoring out a -4. So my x becomes positive and my 16 becomes -4. Taking out that x minus 4 that is repeated, I see an x and a -4 left after I take out that x minus 4. So x minus 4 times x minus 4 is factored form, or you may go one step further and write it as x minus 4 all squared. To the right, I have a 1 as my leading coefficient multiplied by 49. So I'm multiplying to a positive 49 while adding to a -14. So again, I'm going to make my list of options. Since I'm multiplying to a positive but adding to a negative, I'm looking for two negative numbers. So one option is -1 times -49. That adds the -50. That's not what I'm looking for. 49 is not divisible by 2, or 3, or 4, or 5, or 6, but it is divisible by 7. So -7 and -7, which do add up to -14, are the two numbers that we're looking for. So on the left and right of my diamond, I am going to put my two -7s. These multiply to our positive 49 while also adding to our -14. So rewriting my -14m as -7m minus 7m, I factor by grouping. Looking at the left and the right, I see that the left has a GCF of m, leaving me with m minus 7, and the right has the greatest common factor of -7, leaving me with a positive m and a -7 in parentheses. Factoring out that m minus 7, once I factor out that m minus 7, I am left with another m minus 7 in parentheses. So again, we go one step further and write this as m minus 7 all squared. Down to the left, third, I am going to multiply my 1 and -3 to get -3 on top, and I am adding to a positive 2. So now this time I'm multiplying to a negative while adding to a positive. So I'm just going to go through my options real quick. Two numbers that multiply to negative and add to a positive, I'm going to have one positive and one negative number. Now the positive is going to have to be larger since we are adding to a positive number. So when I'm multiplying to -3, one option is 1 times -3. But since we are adding to a positive, I need the positive number to be the larger one. So I am going to write +3 and -1. Now these two do add to my +2, so those are the two numbers that I'm looking for. So again, I'm going to go ahead and rewrite my +2 as +3 and -1n. So n squared plus 3n minus 1n minus 3. And I factor by grouping. Looking at the left, I see a greatest common factor of n, leaving me with n plus 3. And from the right, I bring down my negative, and the only thing these have in common is a 1. So factoring out a -1, I'm left with n plus 3. Factoring out that n plus 3, That leaves me with an n minus 1 in the second parentheses. One more, and then I'll ask you to try the next 4 on your own. Multiplying 1 by negative 70, I'm multiplying to a negative 70, and adding to a positive 3. So again, since I'm multiplying to a negative number but adding to a positive, I am going to have my positive number be larger and my negative number be smaller. So one option is negative 1 times positive 70, or negative 2 times positive 35. It is not divisible by negative 3 or negative 4. It is divisible by negative 5, and that leaves me with a positive 14. It is not divisible by negative 6. It is divisible by negative 7, which leaves me with a positive 10. And when you add these two together, you get the positive 3 that we are looking for. So our two numbers are negative 7 and positive 10. So I'm going to rewrite my positive 3 as negative 7 plus 10 and factor by grouping. R squared minus 7r plus 10r minus 70. From the left, I see an r in common, so I factor out the r, leaving me with r minus 7. From the right, I see a positive 10 in common, so I factor out the positive 10, leaving me again with r minus 7. Factoring out the r minus 7, that leaves me with an r from the first term and a positive 10 from the second. Go ahead and take a moment to pause the video and try the remaining 4 on your own. From the first, you should have n minus 9 times m minus 6. Second, k minus 9 times k minus 4. Third, b minus 1 times b plus 4. And last, r plus 2 times r minus 1. Now when we have two negative terms, we still go about our process in a very similar manner. My leading coefficient is still 1. 1 times negative 9 gives me a negative 9. So I'm multiplying to a negative 9 while adding to a negative 8. So since I'm multiplying to a negative, I need one positive and one negative number. Since I'm adding to a negative, I need the negative number to be bigger. So one option here, when I'm multiplying to negative 9, is negative 1 times positive 9. However, since I need these terms to add to a negative 8, I need my larger number to be negative. So I'm going to multiply positive 1 by negative 9. When I add these two, I do get my negative 8, so our first option is the correct one. I rewrite my middle term as positive 1x minus 9x, and I factor by grouping. Taking out the x from the left, I'm left with x plus 1. Bringing down my negative, I can take out a 9, which leaves me with x plus 1 in my second parentheses. Factoring out my x plus 1, I have x minus 9 in my second parentheses. Go ahead and take a moment to pause the video and try the next 3 on your own. From your first, you should have had n minus 8 times n plus 3. The bottom left, b minus 4 times b plus 3. The bottom right, b minus 10 times b plus 4. The last thing I'm going to add for today is factoring when the leading coefficient is not 1. We still multiply the leading coefficient and our last constant term. So in this case, 3 times negative 12 is a negative 36. Now we're multiplying to a negative 36 and still adding to that middle term of negative 16. So I need two numbers that multiply to the negative 36 and add to negative 16. Since I'm multiplying to a negative and adding to a negative, I need one number to be positive and the other to be negative. Since I'm adding to a negative, the negative number will be bigger. One option is a positive 1 and a negative 36. I have a positive 2 and a negative 18, which do add to my negative 16, so these are the two I'm going to use. Rewriting my negative 16x as positive 2x minus 18x, we factor by grouping to get 3x plus 2 times x minus 6. Go ahead and pause the video and try the next 3 on your own. Go ahead and check your answers, and I hope you enjoy the rest of your day.